All right, today we're going to talk about polynomial expressions and how to add them, subtract them, and multiply them. In a polynomial, we have certain names for them. So a monomial is a number, variable, or product of a number and one or more variables with a whole number exponent. A degree is the sum of the exponents of the variables in the monomial. This may not make so much sense, so let's take a look at our first example here. In this monomial, it is one term, so it's just an 8. It's a monomial, so we'll write yes for that. It's a monomial, and it does not have a degree, so the degree is 0, and that's because I don't see any variables there. I'm going to take a look at B. It's a monomial. It's one term. It's one piece of multiplication, so that's a monomial. And then I take a look at my variable. What kind of exponent does it have? I know it doesn't say it, but look, there's a little mini 1 there. So when I look at this monomial, it has a degree of 1. When I take a look at C, this is one clump of math. I don't see anything being added or subtracted to it. So this is a monomial. So that's a yes. And then to what degree? Well, I take a look at my variable and look at its exponent. It's to the second degree. When I take a look at D, a lot of us will say, oh, it's a monomial and it's to the second degree, but we have to take a look at this. I can't have variables in the bottom being divided if it's a monomial. So what we're going to do is move this to the other side of the fraction bar. When we move it to the other side of the fraction bar, our variable becomes negative. So this is 7x to the negative 2 power. When I look at my definition, remember it says a number, variable, or product of a number and one or more variables with whole number exponents is negative to a whole number. No. So this is not a monomial. And if it's not a monomial, I don't have a degree. Taking a look at letter E, this one is also not a monomial. I know I have a variable there, but it is an exponent. So I don't know if my exponent is a whole number, if it's negative, or what have you. So this one's not a monomial. Letter F is a monomial. When I take a look at all of my variables, it says my degree is the sum of the exponents of the variables. So I have an a to the first power, b to the third, c to the first power, and d to the fourth. I'm going to add up all those exponents. So I have 1 and 3 make 4, make 1 make 5, and 9. So this is the 9th degree. All right, let's move on. I got my answers already there for us. All right, if I have more than one clump of multiplication and it's, let's say, added or being subtracted, then it's called a polynomial. More than one. It's a monomial, or it could be the sum of monomials. The degree is the greatest degree of the terms in a polynomial. So let's take a look. We already said that 8 is a monomial. So is it a polynomial as well? Yes. So this one's a polynomial. Think of polynomial as the overarching category, and then monomial is specific to being just one clump of multiplication. Over here I have 2 terms. So this one is a polynomial. And I look at the highest exponent of my variables, and the only variable I have is this one. It's to the first power, so this is the first degree. When I take a look at the next one, let's see, we talked about this. Is this one going to be a monomial? I've got a variable in the bottom. If I were to move that up to the top, it would be a negative. So this one here is not a polynomial. For letter D, I take a look. It's got 1, 2, 3, 4 clumps of multiplication. So there's more than one clump of multiplication. That makes this one a polynomial. It actually has 4 terms. This is a term, this is the second term, here's the third, this is the fourth. When I take a look at its degree, I want to look at the term that has the highest number of exponents, and that term is right here. And this is a degree 4, or a 4th degree. I add up my exponents. If you're stuck on all this vocabulary, and whether it's a monomial or a polynomial, this is the least of our concern. I'm just going to give you some background information. When I take a look at polynomials, the leading coefficient is going to be the highest degree term, and it always gets written first, and then we decrease our terms as we go. So this first one is a degree 3, the next one is a degree 2, then I have a degree of 1, and no degree for that polynomial. The standard form of the polynomial is in order. So if I take a look at this polynomial, I see 3 different terms, but my degrees are not in the right order. So when I move a term, I'm moving the variable exponent, any coefficient that I have, but also the sign that's right in front of it. So this that I've circled is my highest degree. So that means this is a 3rd degree polynomial. What's the leading coefficient? Well, I'm going to look right here. The leading coefficient is a -1. I have to also, it says, put it in order. So if I rewrite this, I'd have -x to the 3rd plus, because this is a positive 15x, and then plus 3. Now I've got it in order. My leading coefficient tells me the degree of the polynomial. It's the highest that I have. Now that we got all that background information, we'll take a little bit closer look at naming polynomials. A polynomial with 2 terms is called a binomial. So here we go. I've got 1 and 2. Here are 2. There are 2. If I have 3 terms, it's a trinomial. So here I've got 1, 2, 3, trinomial. Again, here 1, 2, 3, 3 different terms, and here as well. See how the terms are separated by either addition or subtraction signs. When we get into adding or subtracting polynomials, this is where we're combining like terms, is what you probably have heard of before. Combining like terms means that my base is the same and the exponent is the same. If I'm adding or subtracting polynomials, what I'm doing is collecting all of the same base exponents, and I'm adding or subtracting the coefficients. So we'll take a look here. I have 2x to the 3rd power. When I look in my second expression here, do I have any x thirds? I do, right here. How many of them do I have? Well, I don't see a coefficient, but I really have 1. So I'm going to put those like terms together. 2x to the 3rd plus 1x to the 3rd gives me 3x to the 3rd. Notice I didn't combine my exponents at all. I'm just making a collection of what is a like. I'm going to take a look at my x squareds. Here I have a -5x squared with a positive 2x squared. When I add those together, I get a -3x squared. I want to look at my next exponent. It's right here, it's a 1. Do I have any other x's to the 1st power? Nope. So I'm just going to bring that down in my answer. And then lastly, and always at the end, if you have any, would be your constant, your plain old number. So that plain old number is right there, -1. So this is my final answer. It has 1, 2, 3, 4 terms. Instead of at the top, I had 1, 2, 3, 4, 5, 6 different terms, and I put them together to make a smaller polynomial. Okay, let's take a look at the next one. I have 3x squared and 1x squared. That makes 4x squares. I look at my x's. I'm going to put a little 1 in front of there. I have 1x and 4x, and I'm adding, so that makes 5x. Then I'm going to go ahead and look at my constants. It's a -6 plus 10. That gives me a positive 4. When I'm subtracting, I can do the same process, combining like terms, but I may want to go ahead and distribute the negative. And what that does is just change all the signs of the second terms. So if I rewrite this, and I haven't done anything yet besides distribute the negative sign, a negative times a negative is going to be a positive 2x squared. A negative times a positive is going to be a -2x. A negative times a negative is going to be a positive 4. I haven't added or subtracted anything. I just went ahead and distributed the negative sign. Now I can put together what's alike. I have 4x squareds and 2x squareds. Well, how many x squareds do I have? 6x squared. Then I look for my next variable, an exponent, negative 2x. And I look at my constants, 5 plus 4, that's 9. Okay, last one for subtraction, I'm going to go ahead and distribute that negative sign and rewrite the second term. That makes it negative 3x squared, positive x, positive 8. And I'm just going to rewrite the first set, and now I can start combining them. 4x squared minus 3x squared gives me 1x squared. Negative 3x and a positive x gives me negative 2x. 5 plus 8, 13. And we're done. The next thing we're going to talk about is multiplying. Multiplying is just using the distributive property. And if you remember your exponent rules, when I'm multiplying like bases, I end up adding the exponents. I'm going to multiply the coefficients, but I'm going to add the exponents. So if I say 2x to the third times x to the third, that's 2x to the 6th. We add those exponents. 2x to the third times 3x squared is 6x to the 5th power. 2x to the third times negative 2x is going to be negative 4x to the 4th power. Lastly, 2x to the third times 5 is going to be 10x to the 3rd power. You'll see you have decreasing exponents here, so our order looks good. If I'm going to multiply two polynomials together, it's really double distribution, and some of you might hear it as FOIL. FOIL is another term that we'll take a look at. Double distribution means I'm taking the x and multiplying it by 3x. So x times 3x is going to give me 3x squared, because I'm adding the exponents. And then I do x times 2. So that's just a positive 2x. Then I'm going to go ahead and cover up the x. We've already distributed that. Now we're going to distribute the negative 4. So negative 4 times 3x is negative 12x. And negative 4 times 2 is a negative 8. After I do this distribution, I have to look to see if I have terms that need to be combined, like the adding piece that we did previously, and that would be right here in the center. Those two middle terms both have just an x to the 1st power, so we can go ahead and combine them. So we've got 3x squared, and when we put this together, we get negative 10x, and then minus 8. As I mentioned, FOIL, it's just a way to help you remember how to do double distribution. Whether you remember FOIL or not, it's not a concern of mine, but FOIL means first, outside, inside, last, and it just reminds you how to do double distribution. I take the first term and multiply it by the first term. I take the first term and multiply it by the last term. That's that first set of distribution. And then I go ahead and do the second set of distribution. The inside terms get multiplied together, and then the last terms get multiplied together. All right, we've got some polynomials to multiply, so I want you to go ahead and practice, and then we'll go ahead and self-check. Make sure you're doing double distribution if necessary. I'll put your answer key up here, and you can take a look.